Hello, so we are the team Webers. We're going to present our course project that we developed through the semester. We made an analysis and a measurement campaign plan about the ground floor in the building 3. We are Fernando Lobato, Joaquín Herrera, Alejandro Ochoa, and Alfredo Ernesto Hernandez, and we're going to begin with the project.
To measure the propagation mechanism of diffraction, we assumed that the transmitter antenna was in the building 2 and we were receiving the signal in front of the building 3, and there was some trees that would cause the diffraction. This is our diagram that shows or approximate measurements of the situation. So here we have the transmitter antenna located at a height of 24 meters. There's a distance between the tree and the antenna of 70 meters, and the receiver is 1 meter above the floor and to a distance of 10 meters from the tree, 8 meters height. We made all our calculations and we could observe a loss of 28 decibels with a frequency of 850 megahertz. Also, the expected height of the antenna is very high, even that it's only 80 meters away, so let's avoid trees for better signal.
Radio propagation measurements, we chose 2 access points in the ground floor and 1 in the lower ground floor. The access points that we chose were from the tech SID, so we were measuring the frequency 5 GHz. This is the map that we developed with the wireless monitor software. So the first access point that we chose is in here. You can see it's really small, and we made the measurements through the floor with a different scale. We were using the scale from -69 dBi to 95 dBi. So the green ones are 69 of strength, and in the red ones you can see the ones of 95, 94. Then we went to the other part of the floor and we also measured, but with the other access point that it's here in the 3107 room. After that we went to the lower ground floor and we chose this access point, and we also measured the strength signal for the 5 GHz frequency. We chose the lower ground floor because we needed to check the reflection mechanism, and we're going to talk about that next.
So for this picture we use a software wireless monitor, and we can see all the signal strengths for floor 1 in building 3. We mark the access point. So for first floor analysis, number 1 and 2 are examples of diffraction effects. In both of those areas, the router is not visible, but there's a corner and the signal strength doesn't decrement radically as we thought it would. Since there were no corridors on the first floor, it's a free space, we have to do some tests on the basement to prove the refractions. So in conclusion, in first floor analysis we can see diffraction effects. For the basement analysis we also use the same software for it. We mark the access point right here, and for basement analysis we can see reflection because in basement is a large corridor. It's not an open space like the first floor for building 3. Also is present transmission loss. This is because there are 2 classrooms right here and it's a wall that separates both classrooms, so the signal of Wi-Fi lose.
Finally, we did a thorough investigation into the allegations of cellular base stations being harmful for human health. The short answer is that they are mostly safe. Antennas are usually arranged in groups that transmit frequencies horizontally. There have been a lot of studies into If these radio frequencies can actually damage human health, the only provable damage that occurs from these frequencies is the heating up of tissue, but it occurs at frequencies that are much higher than the ones that are of legal use by the specific authorities that regulate them inside each country. So radio frequencies between 70 and 110 megahertz are optimally absorbed by the human body. Actually, the frequencies in cellular communications are 100,000 times lower than the waves capable of breaking chemical bonds like X-rays that can cause radiation and decay that can lead to cancer. So yes, they are mostly safe to use. They are safe to install around different parts of the city, and we actually found evidence that Mexico lacks more cellular base stations for a better coverage area. Here we have an image of the frequencies that are used by the cell phone providers in Mexico. The Federal Law of Telecommunications and Radiodiffusion is not so clear about the limits enacted, but it does talk about limits. Currently, the cell phone providers operate at frequencies much lower than those that could cause heating to the human tissue. Thank you.